dispersion. For example, let us consider the 5 observations 4, 6, 9, 3, 7. Solution. Minimum observation is 3, maximum observation is 9. Therefore, range equal to 6. Next. Mean deviation. It is the another measures of dispersion given by the average absolute deviation of observation from measures of central tendency. MDA equal to 1 by n summation modulus of xi minus a frequency data. MDA equal to 1 by summation fi summation fi modulus of xi by minus a. MDA is called the mean deviation around region A. Here A can be taken the any measures of central tendency. Sin x bar means positive value. X1 equal to 3, then modulus of xi equal to 3 and xi equal to minus 3. Then modulus of xi equal to 3. Next. A is the taken arithmetic mean. It is called the mean deviation about mean. For raw data, MDA equal to 1 by a summation modulus of xi minus a. Frequency data, MDA equal to 1 by summation fi into modulus of xi minus x bar. The mean deviation of all the values of the arithmetic mean. It also suffers from all the drawback of arithmetic mean. However, it has more drawback in the sign of deviation. Next. Standard deviation. Standard deviation is another measure of dispersion. It is defined by positive square root of the arithmetic mean. The square deviation of the observation from the respective mean. That is, for raw data, sigma equal to root of 1 by n summation xi minus x bar the whole square. Frequency data, sigma equal to root of 1 by n summation fi mod into xi minus x bar the whole square. It is also termed the square root of the variance. Next. Variance. The variance used the measures of average square distance of the observation from the respective arithmetic mean. It is given by for raw data. Variance of x equal to sigma square equal to 1 by n summation xi minus x bar the whole square. Next, frequency data. Variance of x equal to sigma square equal to 1 by n summation fi into xi minus x bar the whole square equal to 1 by n into summation fi xi bar the whole square minus whole bracket 1 by n summation fi xi the whole square. Using the step deviation method, variance of x equal to 1 by n summation fi di square minus 1 by n into summation fi di the whole square into h square, where n equal to total frequency, da equal to xi minus a equal to assumed mean, h equal to width of class interval. Next. Properties of variance. For x1, x2, etc. xn, y1, y2, etc. yn denotes the two set of the observation with variance v of x and v of y respectively. Also, a and b are any constant. First one, variance of ax equal to a square of variance of x. Second one, variance of x plus b equal to variance of x. Third one, variance of ax plus b equal to a square variance of x. Fourth one, variance of x plus y equal to variance of x plus variance of y minus plus 2 covariance of x comma y. Last one, variance of x minus y equal to variance of x plus variance of y minus 2 covariance of x comma y. Next, property specify that a variance free from change of origin but not of the scale. So, covariance of xy is called the covariance between observation on x and observation of y. It is given by the formula covariance of x comma y equal to 1 by n summation xi minus x bar into y minus y bar. Next. Properties of variance. Sigma square equal to 1 by n1 plus n2, n1 sigma 1 square plus n2 sigma 2 square plus n1 n2 divided by n1 plus n2 into x bar 1 minus x bar root 2 the whole square. Next. Quartile deviation is another measure of dispersion. It is given the half of difference between first and third quartile. QD equal to Q3 minus Q1 by 2. Also provide the better measures of scatterness in the case of rank. As the major drawback that based upon the two observation and ignored all the other values. Therefore, the continuous data is less preferable compared to the standard deviation. Next. Example. Let's consider that three different cases consisting of the data related to the salary of 5 workers, two different companies. A serial number, case 1, case 2, case 3, case 1 plus C1 15, 18, 12, 18, 22, 17, 14. C2 22, 2, 32, 5, 24, 17, 167. Array case 2 C1 15, 18, 12, 18, 22, average 17, variance 14. C2 18, 21, 15, 21, 25, 22, 14. Case 3 C1 15, 18, 12, 18, 22, average 17, variance 14. C2 31, 18, 22, 12, 10, average 18.6, variance 70.8. Next. Case 1. In the case 1, average salary of workers are same for both the companies. But the variance of company C1 smaller as compared to C2. Therefore, one should prefer the joint company C1 as the worker. Case 2. In case 2, variance standard deviation of the salary of workers are same for both of the companies. But the mean of company C1 is smaller as compared to C2. Therefore, one should prefer the joint company C2 as the worker. Case 3. In case 3, mean and variance standard deviation of the salary of workers both as the different for the both companies. Therefore, which company should be preferred? In case 3, the decision about would be the made with help of the measures of relative dispersion. Next. Measures of relative dispersion. First one, coefficient of range. Second one, coefficient of mean deviation. Third one, coefficient of variation. Fourth one, coefficient of quartile deviation. Next. Measures of relative dispersion. First, coefficient of range. Coefficient of range equal to maximum observation minus minimum observation divided maximum observation plus minimum observation. Coefficient of mean deviation. Mean deviation about mean divided mean into 100. Next, coefficient of variation. Sigma by x bar into 100 or standard deviation by arithmetic mean into 100. According to the proved calculation you succeed in this measure, CV is the percentage variation in the mean, standard deviation being considered as the total variation in the mean. Coefficient of quartile deviation. Q3 minus Q1 divided Q3 plus Q1. Next. Example. First example 85, 96, 76, 108, 85, 80, 100, 85, 70, 95. First range. Range is the maximum observation 108, minimum is 70. Range equal to 38. Next, coefficient of range equal to 21.35. Next. For the computation of mean deviation and standard deviation, first the arithmetic is computed the table. For the deviation considered, mean equal to 88. Table of the mean deviation equal to 9.4. Coefficient of mean deviation equal to 10.681. Next. Standard deviation. First example, above example is standard deviation 11.3. Coefficient of variation 12.53. Quartile deviation. First data is arranged in the order, ascending order. 70, 76, 80, 85, 85, 85, 95, 96, 100, 198. Q1 equal to 78, Q3 equal to 95.5, quartile deviation equal to 8.75, coefficient of quartile deviation equal to 10.09. Next. Example, following data represents the wage of workers in a factory. Come to different measures of central tendency. Wages, number of workers. Wages 170 to 180, 180 to 190, 190 to 200, 200 to 10, 210 to 220, 20, 30, 30 to 40, 240 to 250. Workers 52, 68, 85, 92, 95, 100, 70, 28. Next. Mean deviation. The mean deviation equal to 209.07. Mean deviation 16.88. Coefficient of mean deviation equal to 8.07. Next. Variance about data. Variance 89.89. Standard deviation 19.746. Coefficient of variation 9.44. Today my topic is measures of dispersion. Coefficient of variation, range, quarter deviation, mean deviation, standard deviation, variance. Okay, thank you.